that you have an opportunity on the questions and answers to fill out one of the questioning forms, which Bill Minogue has in this corner, Ted Cook in this corner, or a few forms here. I also might remind you that the poster session will be from 1:30 to 3:30 this afternoon in the same room as previously bought a new set of posters. I invite you to go at that time. It was also commented that at the 4 o'clock Wild Animal Park trip, please be sure to order some to-go beavers or getting those good. Now, moving right along, we have heard from the Vice President for Research and Development of a major oil company. Now we're going to hear from a corporate chief scientist, chemical company, on the future role of catalysis in energy processing, the future catalysis for the production of chemicals by Dr. James Roth. Yep. Please be sure you smile when you're on camera. We have Burton Davis who's videotaping this. See how that works out.
Good morning. The future of catalysis as applied to the production of chemicals seems to be somewhat confusing, to say the least. In June of 1986, Chemical Week published a very extensive report on the current state of catalysis. And in this particular report, it was pointed out that industrial research in catalysis in the chemical industry was being dismantled, phased down, and dramatically curtailed. Now, at the very same time, we have the Pimentel report, which identifies catalysis as one of the key intellectual frontiers in chemistry, and which recommends it as one of the top 5 areas for priority funding. Thus, we have a very wide discrepancy between the analysis and conclusions of the Pimentel report and the perspectives and actions of the chemical industry. Now, it's important that we attempt to understand this discrepancy, particularly when we bring into focus the size and importance of catalytic technology. Now, the total worldwide, and this is different from the U.S. data given by some of the previous speakers, the total worldwide annual market for catalysts for petroleum, petrochemical, and chemical applications was estimated at $2.2 billion in a study conducted a few years ago by Chemical High-Tech of Switzerland. The average value of catalyst as a percentage of the product produced therefrom is conservatively estimated as 0.2%, and from these two numbers, one readily concludes that the worldwide value of products made via catalytic technology is in excess of $1 trillion per year. Now, this is greater than the gross GNP of all but a few nations in the world. Clearly, catalysis is a technology of major financial importance. There's every reason to believe that the societal needs that are served by the molecules and materials currently made by catalytic technology will continue. These needs will be served either by the existing materials or replacement materials made in either case, very likely by catalytic technology. What then is our situation? The abandonment of industrial catalysis research could perhaps be rationalized by assuming that the current slate of products of catalysis is surely of large volume, but rather low growth and apparent technology maturity. In short, it's unlikely that new advances will be made that would justify the replacement of the vast current existing technology and associated manufacturing infrastructure. Now, do we have here the same kind of neglect which has contributed to the decline in technology competitiveness that has afflicted our steel and other mature, low-growth industries? I believe that the answer may well be yes, and that many current technologies are in fact rather vulnerable to displacement by radically new approaches or concepts. I will try to describe a few specific examples of possible opportunities for replacement of existing, relatively mature catalytic technology.